Thanks for joining. We were discussing about HR analytics, and we were trying to understand what are the various metrics that HR personnel, as HR personnel, we have to try and look into. And using these metrics, what are the various analytics that we can perform is what we're trying to learn. Analytics is a scientific subject wherein we use scientific techniques or mathematical techniques, you can say. And using these techniques, we'll try to churn the data, right? We will have a lot of data with respect to various touch points about employees, whether the organization, whether the performance metrics, the compensation metrics, right? So various things are there. As part of our HRMS or HRIS, the database repository, we'll have a lot of data. Now, using this data and remembering the metrics that we need to analyze, what interesting facts we can unearth from the data, right? That is about your HR analytics. Now, when we talk about analytics, if you remember, we talked about the 4 stages of analytics. Okay, we discussed about 4 stages. The first stage is descriptive analytics. Here we are trying to understand on what has happened till now. Then we looked into diagnostic analytics, right? Diagnostics. We'll try to identify the reasons on why a specific incident is happening. Then we have predictive analytics. This is where we try to do estimations of some values which we don't know. In short, if I have to talk about the predictive analytics in a very, very jovial front, then I would say predictive analytics is like you're trying to become babas and try to predict the future, right? But yeah, we have to use quantifiable techniques. Evidence-based predictions is what we need. So predictive analytics, where we will try and understand what may happen. And once we know what is going to happen or what may happen, then we will try to use prescriptive analytics. Prescriptions, right? So these are the 4 stages for any kind of analytics that we are trying to do. Like any other task, analytics is also a task. And when we are performing analytics, we need to follow a specific process, a predefined process methodology. An analytics project is also something follows, right? This task also follows a life cycle, just like your software development life cycle or any project management that we talk about, right? So there are specific methodologies that we need to follow. For data analytics, machine learning related applications or development, the standard process which is used is called as CRISP MLQ methodology. This CRISP MLQ methodology stands for Cross Industrial Standard Process. CRISP, Cross Industrial Standard Process for machine learning with quality. Every phase, every step that we take should be evaluated from a quality perspective as well. That's about your CRISP MLQ. It's like a life cycle, and it contains 6 stages or 6 phases. You can see it has been documented here. Now, from a analytics standpoint, we need to understand at a high level what are these various steps. Of course, as a HR analytics personnel, you are not expected to do all these tasks. But it is always good to have the knowledge on what exactly is the process for developing an end-to-end application. In the industry, from a data science perspective, you all are familiar with data science, AI terminologies, right? So from a data science perspective, this is a broad umbrella under which we have various substreams. Like in your HR also, right? You'll have recruitment department, you have payroll department, etc. under the HR. Same way under data science, we have different divisions. Under these divisions, the roles and responsibilities are subdivided. And the first step is generally done by subject matter experts and management people, managers. SMEs, people like you who are into the HR domain, who have experience in that particular area, will be involved here. We'll also have senior personnel who understands the business requirements, who understands the data better. And then we also have management. Right? You also have a manager, right? So for every task, you'll have a manager. Now, what these people do here is, when a customer is coming to us for getting a solution developed, or for example, you are trying to resolve a problem in your daily activities. So you're using the data's power in order to develop a machine learning application to do descriptive or predictive analytics. So first is you need to understand what you are doing, why you are doing, and who are those people who are getting affected by the solution, in what way they are getting affected. To develop the solution, what all various resources you need. Technical, non-technical, software requirements, hardware requirements. So you have to think from a architect perspective. There will be, of course, many people involved when you're trying to gather the requirements. So this is the stage where we will do planning. And from a domain perspective, you will contribute in explaining what is the solution that you are looking out for and why we need to develop this. And how is it going to solve the problem that the organization is facing. And according to the requirements, there will be other people who are going to come from that respective departments who are going to gather all the requirements. Business understanding. Okay, remember this. Once we are done with the planning phase, right? When you do the planning, remember, we'll always have to come up with objective. When you're trying to understand the business scenario, right, there will be a lot of challenges that the business is probably facing. Now, why you are trying to develop a specific solution? What is it solving? Right? You need to be very clear on the exact objective that you are trying to solve. So you'll have to document that. And once you identify the pain area, the exact pain area that you are trying to resolve, then you cannot just randomly come up with any solution. The solution has to be the best solution that can be implemented, right? So there will be a lot of challenges. So you have to work within the limitations of those boundaries or the challenges that are there existing in that particular scenario. I'll give you an example. Your management says that there is a lot of iteration. A lot of people are moving away. So as a HR department, your role is to ensure that this iteration does not happen. Right? Iteration should be controlled. So your objective is to reduce the iteration. Right? You're trying to reduce this resignations by the employees. Minimize, you generally use this optimization terminology. We will have to say minimize the iteration. Now, when you're trying to develop or analyze this requirement, you probably will say that, okay, when you talk to the employees who are about to resign, right? You'll talk to them and they say, hey, HR people, we are not happy with the salary that we are receiving. We want a rise in the salary because the offer that we are going to get in the other company is a little higher. Now, you cannot, right, retain the employee just by increasing the salary, because there will be a budgetary constraint. There will be a limited budget. So your management says that given the budgetary constraints, how can you reduce the attrition? This is something that you'll have to think about. So maybe you're going to say that, hey, we will give you a better designation. We will give you a probably on-site trip. We'll probably say that, hey, if you're interested in moving into a specific team where technical, right, capabilities are mapping to your skills. So you're trying to find out a solution which can help the employee to be retained without increasing the salary. So we need to come up with a solution which can work within the boundaries of your challenges. That would be the most appropriate solution that your organization would appreciate. So this is about your business understanding. And when you are gathering the requirements, you'll also have to document the objectives that we have recorded, and of course, the challenges that we have in that particular business case. These have to be documented, and this document is called as project charter phrase. That's the name given to the document that we put. Post this, we try and understand the data. Whatever the data that we have to use to develop a solution with right, these objectives in place, right? So we need to solve those objectives, isn't it? So in order to solve these objectives, what is relevant data? You need to try and get that relevant data. So data understanding will start by understanding what is the relevant data, what are the data points that are required. Then, right, you need to understand what are the required data fields. Then comes the data collection. You need to also identify where you get that required data, right? As soon as you see a business problem and you identify what fields you need, it does not mean you have the data readily available. Satisfaction score, for example. Your management says that, hey, you need to improve the satisfaction score, which will basically benefit the overall organization in many aspects. A lot of metrics are interrelated. For example, if the satisfaction score is increased, then iteration will automatically reduce. Productivity of the employees will automatically increase, isn't it? So there are a lot of metrics like this which are interrelated. So if your requirement is to try and improve the satisfaction score of the employees, you probably will look into the data which is there in HRIS or your HRMS, whatever that system that you're using, software that you're using. So it includes data in, let's say, table representation. It contains employee age, gender, the location, the address, the team, the manager, the years of experience, the compensation, the salary high, the bonuses or hikes, when is the last hike given, etc., etc., etc. We'll have the details. But do we have employee satisfaction score related data? Maybe not. How will you measure the satisfaction of an employee? So here we will be conducting a feedback survey. We will try to connect with the employees and we will try to gather their feedback. And this feedback will be directly be given by the employees, right? And given this feedback, you will be able to understand whether they are happy or not. This becomes your relevant data, right? So as I said, the data may be present already in the system or may not be there. If the data is not there, then you'll try to get that data. Once you have all the relevant data, then we start doing pre-processing. We don't do processing directly, we do pre-processing. What does this pre-processing mean? The data that we are getting will be in its raw format. It might be gathered from various sources. One of the source could be HRIS, one of the source could be a feedback form, Google form or CSV file, where you have the feedback given. The HRIS system, data could be in a proper table format, in proper organized format, whereas the feedback could be a text data. It is like jumbled, raw format. So we will have to ensure that all this data that we are getting, which is relevant for our business problem, is pre-processed, and then we arrange the data in a proper tabular format in such a way that you will be able to use that data, consume that data for deriving very interesting facts. So you can probably look at this mind map. The link for the mind map will be shared on your YouTube link. You can right the session, right? The live YouTube session now. In the chat, you can see the mind map link. You can click on the mind map link and then come to this particular area. We can see this particular step, which contains 3 different broad sections: data cleaning or organizing, we can say. Then EDA, this is preliminary analysis. And then we can also manipulate the data to create something very interesting further. Right? So feature engineering, we are trying to construct new features from the existing features. It comes by experience. You need to become a subject matter expert here to get to that particular right, say, area where you can also try and create new fields which will be more relevant for your problem solving right scenario. Next. When you have data in its raw format, there will be a lot of challenges, as I've said, and these challenges you can see are documented here. The data types might have to be altered, right? If you have a default data type, right, in the system that you're using, the software that you're going to use, then you may not be able to appropriately work if the data types are by default interpreted. Technically, the data types have to be given in a specific format. For example, you might have salary. But when you're trying to analyze the salary, we generally put these employees' salaries into brackets. This can be defined as levels, right? Based on the designations and all that, we try to map the salary component. Now, salary is a numeric data which can be represented in decimals. From a programming perspective, right, the terminology is called as float data type. It's called as float. But There may be a scenario where you don't need that numeric data. You just need to understand the designation levels. And each level is defining a specific range of salaries. So when you talk about levels, you may say that level 1, level 2, level 3, right? Then manager level 1, level 2 for managers. This could be senior manager kind of a thing. So the designations could be anything. The naming, right? Convention could be anything. But we are trying to represent a numeric data in a non-numeric format. So you might want to change or alter some of these details when you are dealing with your data. So these kind of manipulations is what we are going to do here. And typecasting is one such example where we try to alter the data types. Say, for example, float to integer. Float is in decimals. Integers is non-decimals. Then you may see duplicates. It could be by mistake, maybe a human error, or it could be because of some other reasons. Maybe we have two different systems or multiple systems. When you're gathering the details, there might be duplicates that are arising. Now, we don't want to deal with these duplicates, right? We don't want to rework on something that we already have. Right? So duplicate handling. We try to eliminate, filter out duplicates. We'll only take one form, one original entry. So we can ignore the duplicates or delete the duplicates. Then, what if I have exceptional case? Say, for example, in an organization, let's call it as XYZ. The employees' salaries, when we try to look at, right, the compensations, the packages for the employees in the organization could be somewhere from 5 lakhs per annum, LPA, to, let's say, 15 LPA. Okay, this is basically the salary range for this organization, assume, as an example, assume. But this organization wanted now to hire a specific resource, which is very much required to handle the projects. And because of the demand, right, and the, let's say, quality of the resource that we are hiring, the package could be going to 50 LPA, right? A very senior, experienced person, right? Very highly qualified employee, a person. When you're trying to hire, probably the organization has to give exceptional figure to, right, onboard that particular employee. So when we see this kind of a number, don't you see this is an exceptional value when compared to rest of all the employees? This is very, very exceptional, right? This exceptional case is called as outlier. We give the specific name called outlier. Okay. Now, what if you have this outlier? How do you analyze? For example, this organization has, let's say, 200 employees. Let's assume that there are only 100 employees. Okay, just for our discussion purpose, assume that we have only 100 employees in this organization, out of which you see one employee has an exceptional salary. So if you have this exceptional case or outlier case, then how do you deal with this? Right? So we basically try to follow a certain rule, which is called as 3 R's rule. it's easy to remember this. So this way, so right, you can also follow the same convention, 3R rule. The first R is to evaluate whether this value is a genuine entry or not. We call this as rectify. Are you sure that this employee, the salary that we are seeing, which is exceptional, is actually a 50 LPA? Maybe there is a human error, and the person who's trying to enter the data probably has made a mistake in hearing the value. Maybe this is 15 LPA only, but by mistake it was written as 50 LPA. Probably, I mean, it's a human error. It is always possible, right? So if this is the case, you go back to that exceptional data point and cross-verify. Is it actually 50 LPA or is it only 15 LPA? If it is a 15 LPA, then it is not an exceptional, right? It is a regular value, just like any other data point that you have in the data set. But if it is actually 50, then it is something that we'll have to carefully work with. So the second point is we need to retain it. We have to keep it and then process the data, right? And the third option and the easiest one is remove. If it is just one-off case, then we can simply remove it. Only one person has this kind of a package for the entire staff. 100 people staff is there. Only one person has the high salary. Remaining 99% of the people have regular salaries. So if this is the case, right, if this is the scenario, then we may ignore that 1% because it's purely exceptional and maybe the project-based requirements are there, exceptional case. So if that is the scenario, then we will not include this into the analysis because this is not generic scenario, right? It is a one-off case. You cannot expect that these kind of things are happening regularly. Okay, so that is your remove. Then we talk about retain. Retain means we'll have to keep this exceptional case also and then do the analysis. Right, so this is basically your 3R's rule. Whenever you see an exceptional case, we will have to use one of these strategies to ensure that we either keep the data or remove the data. Similarly, we have zero variance, then we have discretization or binning problem. Binning is something that I've already explained here, right? While typecasting was being discussed. Salaries, there will be a huge range, and these salaries, right, these values are being grouped into different designation levels. That's called as discretization or binning or grouping. All the people who fall in this group probably are junior resources. All the people who are here are senior members. And so on and so forth. We'll try to group the entire salaries right range. Then another very important challenge that you might want to understand is the missing values case. In a lot of data set cases, right, in a lot of data points cases, when we're recording the data, there may be a lot of missing values. For example, your onboarding. You're onboarding a team. So there are various fields that you're going to record for these new employees who are getting onboarded. Okay, this is onboard process, and we are trying to look into various resources and various fields which are helping us to capture these details. Now, when we are trying to record these details, there may be a scenario where some of the fields were not filled by the employees itself. Okay, so if this is the case, then we call this null value as missing cells, missing values. If you have a missing value, then whatever the analytics that we are doing is getting affected because we use arithmetic operations, mathematical operations on the data. And if the data is missing, then what kind of arithmetic operations we will do? This is your data, for example, this row. Assume you have a mathematical equation as ax1 plus bx2 plus cx3 equal to y. Assume. If ax1 is missing cell, it could be any field, right? I'm just at a high level explaining that. If there is a field which is missing, so you probably have x1, x2, and x3, x1 is missing. So I will say ax1 plus a could be any constant again. A could be, let's say, 5. We say x1 plus b could be 2 x2. X2 is, let's say, 100. Some random numbers are that. Okay. Then we have x3. C. C could be 3, and x3 is 10 assume. So when you do the calculation, you'll get y. But can I finish this calculation with x1 being empty? We cannot, right? We will not be able to do that. So what happens is the algorithm, the computer that we are using, the system that we are using, is going to eliminate this entire row. It will not consider this entire row for processing. Okay, that is something we have to remember. That means if I have 10 details, 10 fields about the employee, yeah, if you have 10 fields, one of the field is missing. That means 9 data points are getting lost if this record is not passed. Yeah. So we will get into a data loss problem. Data will get lost. Probably this is a very senior employee or very important employee. And just because, let's say, the age field is missed, right? You cannot ignore the remaining values, right? But mathematically, if the cell is missing, then the entire row gets lost because your computer cannot finish the mathematical calculations. Similarly, we have dummy variables, right? Let me show you a data set as an example. Okay, just a glance, a very simple data. I'll quickly show you the glance of this data. This is your employee data, very simple HR example. So you have employee name, employee ID, the designation, which location, state, and the zip code, gender of the employee, marital description, or marital status, you can say, citizenship status, the employment status, and then which department the person is working. Then what is their salary, what is their age, and what is their race. So this is our small example data set, and what you can see here is employee ID is just an identity, like a name. You cannot use that identity value for mathematical operations. Yeah, you should not be using them for mathematical operations because ID is like a representation. On the representations, you cannot simply do mathematical calculations. So these are just used for reference. Then position, this is the designation, state, and the zip code. Zip code is also to be interpreted as an identity for a specific location. Okay, it's an identity. On the zip code also, I will not be doing any mathematical computations because it's just an identity reference point. Then we have salaries and age. So in short, I can see only salaries and age which are numerical nature. And rest of all the values, the designations that you see are non-numeric. So if it is non-numeric data, should we not consider that data? Should we ignore all these columns because we ultimately do a mathematical equation, right? I just have written that ax1 plus bx2 plus cx3 equal to 0. So if you have such mathematical equation, then how do you manage this mathematical equation using this non-numeric data? All this is non-numeric data only, right? So we are trying to understand how this equation can be calculated. So very simple, friends. Here, let us assume this particular column, gender column. It's very easy to explain this. So let me just try to start from it. Remember, we are doing arithmetic operations. So why not convert this particular value into a numeric representation? It's easy, right? We can simply convert this data into a numeric representation, and we call this as dummy underscore sex column. So it's a dummy variable that we are creating for this particular column. And what we do is, for female, we'll put 0, for male, we'll put 1, alphabetical order. 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. Right? This way we have zeros and ones. So we have successfully marked the data on a numeric scale. So we'll say 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, right? So on and so forth. Now, if you see, this data is converted to a numeric value, right? So I'll be able to do arithmetic operations using this column. Now, I can also look at designations. Position column. Now, when you talk about position, there are designations, and these designations are represented in hierarchy. Right? The designations are always having some order to it, right? Natural order to it. So using that order, we give the preference to the respective designations. Now, in this example, I'm trying to draw alphabetical order, which is the default way. Okay, D underscore partition. And as I said, this is the dummy variable that we are creating, and we are putting the details in alphabetical order. Yep. So on and so forth. The numbering that you are seeing is going to tell us the significance of an important variable. And we can rearrange the numeric values here based on the preference of this particular position designations. CEO or the founder of the organization will be at the top. Then we'll have directors, vice presidents, right? Whatnot. I mean, some designation will be already there, so we'll have to ensure that the data is partitioned. Now, what if I have data like this? Okay, let me talk about marriage description. If you are married, probably you'll have some opinion here, but if you're not married, try to grasp this. If I look at this married column, and if I have to create a dummy column here, right? If I have to put dummy columns, then I'll get 0, 1, 2, 3, 4. So we are recording these numbers, right? So single is 2, married is 0. So on and so forth. Now, if I give this numbering, then there is a small problem. That is, why do you think married is having low weightage compared to separated? Yeah. Right? Important question. Why is married taken as 0, whereas separated as given a value which is 4? So are we saying, by looking at the numbers, are we saying that you give more weightage to supported values and do not give importance to married value? No, right? We cannot show that disparity here or favorism here. We need to treat this, everyone as same. Right? And to do that, to get that, we are basically putting another strategy. We cannot give different numeric values to different categories here, because that would influence the overall mathematical calculation, right? So what we do here is, it's called as, this process is called as one-hot encoding. One-hot encoding. The one-hot encoding basically says, look at the unique set of categories that you have. So total 5 are there, right? So what we will do is we'll create 5 dummy variables. Without, and finally we have dummy separated. So we have 5 new columns created rather than 1 new column, and wherever you see the value, okay, this one, because the first record is married, we'll mark that as 1. The remaining values is 0. The second record here is diversed. So this becomes 0, this becomes 0, this becomes 1, this and this becomes 0. Right? So on and so forth. We basically try and look at what factor we might want to do. This is called as one-hot encoding. The designations thing that we have done, right, where we just created a new single column, is called as label encoding. Okay, so we have one-hot encoding and label encoding. These are the two techniques which are broadly applied to convert non-numeric data into numeric form. Okay, non-numeric data is converted to numeric form. Now, once I have data converted to numeric form, then no problem, I will be able to do the mathematical calculations. That is your dummy variable creation. Then we have transformations and standardization. Now, this is important, standardization, normalization. These techniques, right, these standardization and normalization are the techniques which are used for ensuring that the template that we share, right? What basically I mean is, when you look at the data set, okay, let me put it this way. When you have a data set, you might have different columns. Okay, different fields are there. Assume that we are only talking about numeric fields, okay, like age. We have seen gender, which is converted to numeric levels, right? When we talk about the salaries, okay, all this. So we have gender, we have salaries and age. Okay, you also probably have number of hours clocked in by the employee per day. So on and so forth. When did you get the compensation hike? That is your right salary hike, etc. So we get this sheet, and what we'll try to do now is we'll try to ensure that we compare the magnitude, compare the values of the columns. Now, when you talk about age as a column, it would be generally a 2-digit number, right? It will be a 2-digit number. Whereas if you talk about the gender, it is 1 digit, a single number. But when we talk about the, let's say, number of hours, right? Hours at work. When we look at this time, probably this is again a 1 hour or 2 hours time delay overall. Right? Now, what if we record it in minutes? The number can go up to 3 digits, right? So the number of hours at work in minutes can be a 3 or 4-digit value. So on and so forth. So now when you look at the magnitude here, all of them have different magnitudes, right? So we need to ensure that the magnitude of the data points is similar or same for that matter. Right? So we apply different techniques here. One is called as normalization, which is also known as min-max scaling. The other one is standardization. So standardized scaling and min-max scaling. Min-max is a very popular and very easy model, which can be implemented by a lot of customers. On a lot of data. But what we're trying to do is alter the scale. So when you alter the scale using this formula, x minus minimum of x divided by max minus minimum. Okay, max minus minimum. When you try to substitute the values into this formula, the data points get converted to a range of 0 and 1. See the magic. I'll take the data. Let's say we'll take salaries in let's say dollars, or maybe we'll talk about age. I have age 20 years. I have age 50 years, 35 years, right? Or 28 years, right? And let's say 40 years. Some random numbers I'm taking, okay? Now let us look into the values here. Okay, this is your age of the employees. Look at this formula. The minimum in this is 20. The max is 50. The denominator says difference between these two. We call it as range. This is 50 minus 20, which is 30. We have the required calculations. Denominator is 30. X is your data point. And minimum of x is 20 here. We identified that. Now we will do normalized data. We're doing normalized data. So what happens? We'll use this x value into the calculation. 20 minus what is the minimum? Minimum is 20. Right? This is 30 in the denominator. So 20 minus 20, we got 0 here. Then we talk about here 50. Now I'll take 50 into the equation, minus 20 by 30, which is 30 by 30, which is equals to 1. So the minimum value, the least value in your data set is converted to 0. The maximum value that we have here, which is 50 in the data set, this is converted to 1. Okay, 50 and 1. And the remaining values which are always lying between these, right? So I have this range. I'll say this is 20 and this is 50. If I'm trying to convert this, I'll get 0 here and 1 here. That is pretty straightforward calculations we have seen. But all the data points which are in between will also have to fall here on the same scale. Okay. This process is called as normalization, which will ensure that the numeric advantage is not given to any one of the data set. I mean, any one of the columns. All the columns have to be treated equally with respect to the magnitude. We also have another formula called x minus mu by sigma. We will need to understand what is mu, what is sigma to understand this particular calculation, which eventually we are going to do. So tomorrow I will be looking into a specific data set. Okay, I'll talk about one specific data set or maybe 2 data sets. This is a very simple logic. I will show this data. Yeah, this is the data set. We have years of experience and the salary that is given to these employees. Years of experience and salary. What is the relation between these 2 columns? That is something that we are going to understand. Then we also have another case where we have employee engagement. So here in this case, we have working hours, the number of hours the employee has worked, what is the overall experience, and what is the age and what is the salary of the particular employee. And we are looking at engagement, the engagement levels. Okay, it is given in the percentage form. So given this data set, how you measure the engagement is what we are going to learn. So this is in store for us tomorrow. The software that you're seeing on the screen is called as Python programming interface. This is a graphical user interface wherein we are doing Python programming. This is called as Spider. To understand more about the Python programming, you can refer to the YouTube channel, right, of 360DigiTMG, where we have free Python sessions also conducted, completely free, absolutely free. Python is going to become something like very mandatory thing, like computer skills, like you have MS Office, right? A majority of the people have basic understanding about Word document and Excel files, right? This is like a mandatory skill. If you know computer, you'll be able to understand these two also. Microsoft. On the same lines, we have Python programming becoming mandatory day, right? As in how the days are passing by. So to ensure that everyone is equipped with this mandatory skills in their today's generation, we basically give the training of YouTube completely free. Yeah, you can subscribe to the YouTube channel and you get to know all these latest things. So in the YouTube chat, you will be getting the YouTube, the Python sessions link also. You can click and then go to the appropriate videos for skilling yourself into Python programming. So we will be looking into a use case on how we can predict salary of an employee given a experience of that employee. So if I know the experience, then what could be the salary? Now to define this, we will have to understand the relationship between the salary increment and the experience increase. And we mathematically define the relationship. Right? So we will talk more about this in next session. We'll also have very, very interesting use cases here. We have already seen another data set, which is talking about the engagement levels, right? So how can you measure the engagement levels of an employee? Given the fields, whatever the data fields that we have, within that, do we have any relationship? So that is something that we are going to look into in tomorrow's class. And as I said, exciting things are coming up. Do join us back tomorrow at the same time, 6 p.m. IST, to continue our discussion and learn very interesting insights into the HR analytics implementations. Thank you so much. Do take care of yourself, and let's connect tomorrow evening. Good night, everyone. Thank you once again.